Welcome to the House of Maths. Today I'm going to look at quadratic equations. This is just my introduction to it. So here is a quadratic equation. That's the general form of a quadratic equation there. We've got no numbers in there, we've just got some letters A, B and C. These letters A, B and C are just called coefficients. These positive signs are in there just in the general form, so they could be negative, it wouldn't matter. So a quadratic could look like this. Okay, so I've put the coefficients, I've actually assigned numbers to the coefficients, so that would be a quadratic equation. Why are they called quadratics? Well, it comes from the word quadratus, meaning square in Latin, and the x term, as you can see there, is squared. So that's where the word quadratic comes from. Now, the a term cannot equal 0. If it was to equal 0, you wouldn't get a curve, and the quadratic equation is going to give you a curve in the end. We'll see how that works in a minute. But if a is 0, then this whole term is 0, and then you're not going to get a curve. So a, for that reason, cannot equal 0. It can be positive or negative, any fraction, whatever. Okay, so that's what a quadratic equation looks like. So if we were to assign some values to x, that would generate an output. So if I made x1, we would get an output, not 0. If I made x2, we would get another output, and so on. So we could generate some coordinates from that. We could generate some x coordinates by just putting in 1, 2, 3, 4, and that will generate some y coordinates. And we could then plot this on a graph. So if we did so, what we would get is a curve a little bit like that. And it's a special type of curve. It has this name. It is called a parabola. And it is symmetrical about this point here. So consider that red line like a mirror line. So either side of it, the curve is exactly the same. So what are these quadratic equations used for? Well, they've got a variety of uses. I'm just going to mention one, and that is if you consider a projectile. So imagine throwing a ball through the air. It would take that kind of path, and that kind of path, that's motion under gravity, and it is a parabola. So you could put in numbers into your quadratic which would model that path. So that's one use for it. So let's have a little look at what happens with these values, these coefficients I put here. What do they mean? And what happens if you assign values to them? So initially, let's have a little look at if we just consider x squared, this term here. So in this case, a is 1. Don't write it in. The convention is we don't put 1 in there. We just assume it's there. So if your quadratic's got an x squared, it's going to give you a curve. It's going to give you a curve like so. If your term is negative, like that, it's going to give you a curve that way round. Okay, so x squared positive value gives you this U shape. Negative value is going to give you this N shape. Okay, now obviously in these cases, A is 1 in both cases. what happens if we change the value of a? What happens if we make it bigger? So we make this 5, for example. What would happen to this parabola? Well, it would be squeezed like that. If this goes above 1, the higher it goes, the more it gets squeezed. If we were to have, say, for example, half x squared, it would flatten it out more like that. So the a coefficient can squeeze it in or can stretch it out, depending on whether you go above 1 or below 1. Now let's have a look at the b coefficient. What does that do? Well, the b coefficient moves it in the left and right direction. So it's going to move the curve either that way or it will move it that way. Now, looking at it, you might think, well, if b is positive, it's going to move it that way. If it's negative, it's going to move it that way, but it doesn't work like that. It's the other way around. So if I had a quadratic equation that was, for example, something like that, you might think, oh, it's got negative here, and I know that moves it this way or that way, so it's going to be kind of over here because this bit's negative, but that's not the case. That won't be where it is. If that bit is negative, it will actually shift the curve in that direction. Okay, so this term here, if it's a negative term, it's going to be shifting the curve over into the positive x direction. If it's positive, it's going to be shifting it this way into the negative. Now, what about the last term, the -2, or the c coefficient? What does that do? Well, this one here, this is telling you where the curve intercepts the y-axis. And as you can see, as I've drawn this one, I've looked at that -2 and thought, that's going to go through the y-axis at -2. So the c coefficient is going to tell you where the curve crosses the y-axis. Okay, so the a one tells you a little bit about the shape. Is it U-shaped or N-shaped? The bigger the value a is, it's going to squeeze it in. The smaller the value, it's going to open it out. The b coefficient tells you where the curve is orientated, if you like, on the x-axis, and the c1 tells you where it intercepts on the y-axis. Okay. Right. So one of the things that you have to do with quadratics is to solve them. So you end up with an equation like this. If I put one with some numbers in, well, we have to solve it. What does that mean, solve it? What we're trying to do then is find the values of the value of x, which is going to give us an answer of 0. So what does that mean? If we think about our curve, there's our quadratic, where it equals 0. Well, these are these points here. Okay, equals 0. This is where x is 0. Okay, so that's what we're trying to find. What values of x do we need to put in to give, the y value is 0 here. Okay, so that's what we're trying to find. So these are called the roots, or the solutions. Now what you can have, obviously in this one I've drawn here, I'm showing you that there are two solutions to this quadratic equation. Now they don't always have to be two solutions. It's possible that there could be one or no solutions. So what would that look like? So if it's going to have one solution, it could be that the curve looks like this and it just touches the line at one place. So that is going to be your one solution. And the curve could go, it could be that it's coming in that direction and just touches there. So one solution. But also the curve could be, there's no reason why it couldn't be there, in which case it doesn't generate a zero. Yeah, it doesn't cross this x axis. So it's going to have, this one will have, if it's like this, it will have no solutions. So three possibilities: two solutions, one solution, or no solutions. Now there are different ways of working out the solutions. Okay, you can, as I've just shown you there, you can solve this graphically. So you can plot the quadratic and see where it crosses the x-axis, and that's going to give you your solutions. That's one way you can solve them. You can also solve them by doing something called factorizing. So if you've got your quadratic equation, you will end up with something, I'm just making these up. So you could end up with a factorized solution like so. You can also use something called the quadratic formula. So again, this is something that you would have to remember, and it would give you the solution. It looks like this. So that is the quadratic formula. So if you've got a quadratic equation, here's a general form of it. You've got minus b, so this is going to go in here, b again. You've got an a from here, c from here, and an a again from here. So if you plug in the a, b and c into this, it will give you two solutions, or one solution, or no solutions in certain circumstances, depending on what the values are. So you can use this formula. Okay, I will show you in a subsequent video how to get that formula and how to use it. And also you can do something called completing the square. If you complete the square, you will end up with a quadratic looking a little bit like this. Okay, that is the completed square form. Again, don't worry about it now. I'll show a video on how to do this and how to solve them using that. What this does give you, it enables you to solve the quadratic, but it also, the c coordinate here and the value of x that will make the contents of the brackets equal 0 will give you either the minimum or the maximum point on the quadratic curve. So if you've got a curve, say, that looks like that, then the c value and the x value will give you the coordinates of that point there, which in this case is going to be a maximum value for that curve. If the curve went the other way round, like so. Again, these two values here would give you the value of, or the coordinates of that point there, which would be a minimum point. There was the lowest value of that quadratic curve. Okay, so that's completing the square. And again, we'll look at that later in another video. Finally, from that quadratic formula, the little bit in the brackets, sorry, in the root sign, this bit here that was in the root sign on the quadratic formula, this thing here is called the discriminant. And if you put in the values from your coefficients into here, you will get an output from that. And if the output is positive, that will give you, or it will tell you, that there are two roots, two solutions to the quadratic. If you plug in the A, the B and the C and it equals 0, your answer, that will tell you there is one root. And if you plug in your values and you get a negative value, it will tell you there are 0 roots. So the discriminant is quite useful for telling you that. Okay, that's my very brief introduction to quadratics. I will explore them in a little bit more detail in subsequent videos. So if you like that, remember to hit the like button and think about subscribing. Thank you very much.